Normality is one of the most common assumptions of statistical tests. To check for normality or to make sure that your variable is normally distributed, you can use a histogram to check visually, or you can also use skewness and kurtosis values, which you can get through the frequencies or descriptives SPSS commands. When you request these values, SPSS will give you the coefficient of skewness, the standard error of skewness, the coefficient of kurtosis, and the standard error of kurtosis. So to identify whether there is an issue with skewness or kurtosis, you need to compare the coefficient to its standard error. So as an example, we'll use these statistics for grades on a final exam. So to check whether something has significant skew, you compare the coefficient to its standard error, and you first times the standard error by 2. And if the coefficient is larger than twice its standard error, then there is a significant issue. So in this case, I take the standard error of skewness and I times it by 2 to get 472. The coefficient of skewness is only 0.335, so it is not bigger, which means that there's no significant issue with skew. You can also check for kurtosis by timesing the standard error by 2 and seeing whether the coefficient of kurtosis is larger or smaller. So this one is smaller than twice its standard error, so there's no issue with kurtosis. So in this case, our variable can be considered normally distributed. In the next example, we have final percent grade in the course. And again, we can use the same method. So first I'm going to do skewness and do the standard error of skewness times 2. And you can see that the coefficient of 0.834 is larger than twice its standard error, which means that there is a significant issue with skew. So at this point, you don't have to worry about whether it's negative or positive. You're just looking at the magnitude or how big the number is. Because 0.834 is larger than 0.42, there's an issue with skewness. And then we can look at kurtosis at the bottom. We take the standard error of kurtosis and we times it by 2 to get 934. In this case, the coefficient is larger than twice its standard error, so there's also an issue with kurtosis. To interpret what those issues are, then you can look at the sign of the coefficient. So for skewness here, we have a negative value, which means that there's negative skew. So we can say that our data is significantly negatively skewed. If it was a positive value, that would indicate positive skew. For kurtosis, we have a positive value, which means that we have leptokurtic data, which means that it's too peaky or has a higher peak than normal. If this value was negative, then that would mean that our data is platykurtic. Platy meaning flat, so our data is more flat than a normal distribution. So in this case, because we have an issue with skew and we have an issue with kurtosis, it means that our data is not normally distributed.